Hello and welcome back to another exciting day with math. We're going to be doing more with volumes, more specifically volumes of prisms. What you need to do for today's lesson is how to find the area of a 2D shape, and we talked about areas before, and they're the equations that we use for those other polygons, and also the volume. Generally, that volume is the space inside an object. Think about cubes inside objects of different sizes. That's why we get cubic units from. Alright, so here we go. Now, what are prisms? Well, you might think of a prism about those objects that you play with that refract light and make these rainbows. And now those are prisms, but for geometry, prisms are going to be 3D objects that have two end sides that are congruent and parallel, and all the other sides are parallelograms. So congruent means that they're the same shape and size, and parallel means that they're two lines that never touch, even if you extend them way out. So parallelograms are polygons that have opposite sides that are parallel. Now going back to those prism objects that we had in the beginning, these are actually 3D objects that are shaped like prisms. Surprise, surprise. Now these are 3D objects with opposite faces that are triangles, as you can see here. Okay, now I think it's time for a game. Select that prism. So I'm going to show you some objects and you're going to tell me if they are prisms or not. Object number 1. Object number 2. Object number 3. Nope. Ends don't match. Object number 4. Nope, they have different widths. Object number 5. Well, without the bow, yes. Our last object, a cylinder. So this jar can be treated like a prism because it has two sides that are the same or congruent, and they have a width that's consistent along the way. And if you take that side and wrap it around here and unwrap it, you get a parallelogram, just like we talked about before. So now that we have this, let's go ahead and find the volume of an item like this. If we know the area of the top, I think we could find the volume of the entire thing. So the area of the ends of the jar are about the same as that cracker. Now, if you take the cracker and you multiply that area by the depth or the distance between the two ends of the jar, then you get volume. When calculating for the volume of a prism, we're going to use the equation V equals A times D. Now A is going to be the area of the two sides that are congruent or the same, and D is going to be the depth or distance between those two sides. When you multiply those two together, then you're going to get the volume. Let's look at some physical examples. This stack of books is like a rectangular prism, with the covers being the sides that are parallel. You can see again another stack of books where the front and the back of this stack are the parallel sides. You could even use quesadillas for a triangular prism. I think we're ready for some example problems. Let's go ahead and try some out. Example number 1. We're going to look at a rectangular prism. Now we're going to use our formula V equals A times D. Now remember what we used before. We looked at a stack of books and we looked at the parallel sides and the depth of that stack. We could do the same thing for this rectangular prism by looking at the areas at the ends, those are parallel and congruent, and then looking at the depth, the distance between those two sides. And now we could put our calculations together. It's length times width, since the area is a rectangle, and the depth we could add in there. Yes, that distance between, so we have 6 times 8, 48. Make sure you box and you put your units on your measurements. Now remember, if I am going too fast or if you miss something, you could always stop the video and watch it again. So now we're looking at other examples of triangular prisms. Here you can see we use pizzas and chips. Now, can you guess which sides we're using for those areas? Yep, we're going to use those parallel sides that are congruent for the areas and the distance between them for the D value that we're looking for. So here is example number 2. It's a triangular prism, and we are going to use V equals A times D, same thing we used before. Looking for the areas, this time it's a triangle, so we're going to look for that base times height and divide it by 2 and add that in for the area. Use the depths, plug in the numbers of the values that we know, and then always make sure to box and to add our units. So here's number 3, this one's for you. So we have a parallelogram that is a prism, and we have these values together. Why don't you go ahead and try to see if you can write those calculations out. This is probably a good time to pause and work on the problem a little bit on your own. How'd you do? Need a clue? You could always use V equals A times D to start you off. So for a parallelogram, the area is going to be base times height, and then once you have that, you could just plug your values in, box your answer, and don't forget your units. Now the shapes that we use for our prisms can be a little odd. It could be like shape of bread, or it could even be a shape of a pineapple kind of to a star. Now you should be able to calculate the volume the same way for all these shapes. Now let's look at a pool. The pool has a weird shape on top, and we'll give that an area of 20 meters squared. Now you could use your equation we had before and just go ahead and plug in the value for area into that equation and use the depth of 3 meters to calculate your volume. Pretty simple. So here's another quick example for you. Sometimes our shapes are compound shapes or complex shapes. They're not our natural shapes. So we have to add up shapes that we know how to calculate the area for in order to find the volume. So here we're going to use the volume equation, but we're going to use A1 plus A2 to be the total for the whole area. That way we can calculate the entire volume of this prism. So putting our values in, we're going to get 150 units cubed for our volume. So this last example, example 6, is for you to try on your own. Do you recognize the shape of the face that you're going to use to calculate the area? Go ahead and pause and try to see if you can figure it out. Working, 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 calculating volume. Woohoo! So how's it going? Do you need another clue? Well, that shape is a trapezoid. Do you got it now? Go ahead and pause and see if you could solve for the volume. Alright, here comes the answer. Now, does your work match ours? I hope so. Well, that just about wraps up Volume of Prisms. Hopefully you learned something new and you had fun doing it. See you next time. Alright, so I have one last bonus question for you guys. Now, using this stack of paper, what I want you to do is calculate how many pieces of paper are needed to build a stack as tall as you. So this is not exactly volume, but you need to use those same skills in order to find how many pieces of paper are needed to make a stack just as tall as you are. So go ahead, do a little research, and see if you can get the answer back to me. Alright, talk to you later.